Welcome to Inside the Future.
Glad to be here.
So if you wanted to build the ultimate machine to, carry heavy boxes across a warehouse, you'd probably just give it wheels, right?
Or tracks or something.
Exactly. Or, if you wanted a machine to weld car frames together with microscopic precision, you would just bolt a specialized arm directly to the factory floor.
Yeah, you wouldn't make it walk.
Right. So why are the world's top engineers and tech companies spending billions of dollars trying to build robots that walk on two legs, balance awkwardly, and basically look exactly like us?
It is a really good question.
Today, we are unpacking a fascinating stack of research titled Humanoids, When Robots Begin to Look and Work Like Us. And the mission of this deep dive is to really understand the imminent reality of physical AI.
And it is imminent, yeah.
Totally. And if you are a student tuning in, maybe you're sitting in your dorm room right now or commuting to class, and you are wondering how you are supposed to plan a career or pick a major when a literal humanoid robot is getting ready to enter the workforce, this deep dive is going to map out exactly what that shift means for you.
It is a huge shift.
It really is. But getting back to that first question, this was a real aha moment for me in the research. The reason we are making machines look like us at all, it's not because of sci-fi nostalgia.
No, not at all.
It's actually a practical engineering shortcut. Because instead of completely rebuilding our factories and offices and hospitals for wheeled machines, it is just easier to build a robot to fit into a world that is already designed for human bodies. Stairs, doors, tools.
Yeah, it sets a really calm, analytical tone when you look at it that way. I mean, science fiction always focused on humanoids looking human for dramatic effect, but the engineering reality is purely about functional adaptation to our existing environment.
Right.
The research has this brilliant analogy. Think about the infrastructure of our entire civilization. Every factory floor, every hospital corridor, every flight of stairs, the door handles.
Using hand tools.
Exactly.
Yeah.
Every single hand tool has been uniquely designed around the physical dimensions, the reach, and the joint articulation of the human body. We are the key that already fits the locks of our world.
Which makes perfect sense when you say it like that.
Right. Because if you design a highly efficient robot with expansive rail systems or wheels, well, suddenly you have to retrofit your entire multi-million-dollar warehouse just to accommodate it.
Oh, wow, yeah. You're pouring concrete for ramps.
Widening doorways, totally redesigning everything. It is vastly more cost-effective to just build a robot that fits the human world than to redesign the environment from scratch.
So to understand how these robots will actually navigate that human-built world, we really have to look at what's powering them, right?
Right, the intelligence behind it.
Because we're transitioning from the AI we all know on our screens to AI moving through physical space, and the source text defines this as embodied intelligence, or physical AI.
Embodied intelligence, yeah.
Because up until now, the AI revolution has basically been trapped behind screens. Writing essays, generating images, making video.
Just manipulating digital data.
Exactly. But humanoids introduce AI that can act in the physical world. And the source breaks down the immense complexity of what seems like a really simple task.
Oh, the box example.
Yeah, instructing our robot to just go grab boxes from a loading area, separate them by label, and put them on shelves. To us, that's nothing. But for a machine, it requires language comprehension to hear the command, plus computer vision and object recognition.
Just to know what a box even is.
Right. And then navigation and delicate dexterity to actually pick it up without crushing the goods inside.
Which is incredibly hard. A digital AI only has to navigate data, right?
Sure.
But a physical AI has to navigate gravity, physics, and unpredictable spatial friction.
And it has to balance its own weight while doing all of that.
Yeah, constantly adjusting the torque in its knees and ankles with every single step. It is taking in millions of data points from sensors, cameras, and gyroscopes, making real-time micro-adjustments just to literally remain upright.
It's staggering when you really break it down, and that complexity is why there's this massive 2026 global race going on.
It's highly competitive right now.
Right. We have major players competing to make this a reality. Tesla with their Optimus humanoid, Figure AI, Boston Dynamics, and then you have companies like Unitree and UBTech.
There's even the World Humanoid Robot Games in China, right?
Yes. China is turning this into a massive spectacle. Okay, let's unpack this, because I watch those viral videos of robots doing backflips or, walking across the stage, and I'm a bit skeptical.
I think a lot of people are.
Because walking across a well-lit presentation stage is just an impressive demonstration. It's a choreographed parlor trick. How do these machines transition from a 10-minute demo to working an unpredictable 8-hour shift safely alongside humans?
What's fascinating here is that the engineers share that exact same skepticism.
Oh, really?
Yeah. The text is very clear that the real race isn't an athletic competition or going viral on social media. It's answering one fundamental question: can it work safely and economically?
Because an 8-hour shift is a whole different ballgame.
Completely. The challenges are immense. They need better batteries, for one. Just balancing on two legs drains power constantly. And then you need greater reliability, safer movement, and of course, lower costs.
So they aren't going to be walking around our living rooms as home assistants anytime soon.
No, absolutely not. Because unpredictable environments, like a messy living room with toys on the floor, are computationally exhausting.
Because every time it encounters a stray shoe, it has to recalculate everything.
Exactly. So they are going to start in highly controlled commercial environments.
Right.
Places that are mapped out and standardized.
Like warehouses and factories?
Yes.
Yeah.
In those spaces, humanoids will do the physically demanding, repetitive work. Loading, unloading, sorting, and just moving goods alongside the automated systems that are already bolted down.
Just doing the heavy, brutal lifting.
Right. And the other major area the research highlights is healthcare and elderly care.
Which makes sense with our aging societies.
Yeah, the demographics are putting a huge strain on the medical system, so robots will transport supplies, deliver medications, and assist patients with mobility.
Like getting in and out of bed. Think of the humanoid not as a replacement doctor making, medical diagnoses, but as the ultimate hospital orderly.
That's a great way to look at it.
Because by taking over the heavy lifting and the endless transport tasks, it frees up human nurses and healthcare professionals so they can spend more time actually providing empathetic patient care.
Exactly. And the so what factor here is that the most valuable robot of the future won't be the one that looks the most convincingly human.
Right. Doesn't need a super expressive face.
No, the most valuable one will be the one capable of working for hours without constant human intervention. Pure, reliable utility.
But, while performing those repetitive tasks in warehouses and hospitals is revolutionary, there is another capability in the research that gets way less attention.
The extreme environments.
Yes, moving these robots from mundane spaces into incredibly dangerous ones.
This is a huge priority for the industry.
Because we can deploy these machines into situations that are lethal for people, like entering burning buildings before firefighters to check structural integrity, or operating inside chemically contaminated zones.
Or assisting rescue teams right after an earthquake, moving rubble in unstable areas.
And the research also talks about the industrial application of remote operation, where a human operator safely controls a robot doing a highly dangerous job, like deep underwater welding from miles away.
Telepresence. It's an incredible application of the tech.
Here's where it gets really interesting. Society is so completely obsessed with the narrative of robots replacing humans. The whole human obsolescence anxiety.
Yeah, the Terminator fears.
Exactly. But the source explicitly outlines how, in these scenarios, humanoids are actually about protecting humanity. They are extending what humans are capable of doing without putting human lives on the line.
It shifts the entire paradigm. We go from worrying about human obsolescence to focusing on human preservation.
Preserving our safety.
And preserving our autonomy. It scales down to the individual level, too. Think about elderly people being able to maintain their independence in their own homes for much longer.
Oh, because the robot absorbs the physical friction of daily life.
Exactly. Carrying groceries up the stairs, reaching high shelves, doing laundry. The humanoid isn't replacing human connection. It's preserving that person's way of life.
That is amazing. But if robots are taking over warehouse floors and entering burning buildings, it does force us to confront the most uncomfortable question in the research.
Will they take our jobs?
Yeah. Will humanoids take our jobs? And this is where we have to look at the students and the future workforce. Because automation changes tasks, but it also creates new professions.
Entirely new career paths.
Right. The text points out that we are going to see new jobs in robot operations, maintenance, training, fleet management, safety protocols, and software.
Because the transformation happens at the task level, not the job level.
That distinction is so important.
It really is. A nurse's job is a bundle of tasks: assessment, medication, emotional support. The job remains essential. But the specific task of moving heavy boxes of IV fluids, That gets carved out.
And assigned to the humanoid?
Right. Same for a warehouse employee. They don't just disappear. Their role shifts. They go from manual lifting to becoming an operations manager, supervising a fleet of machines.
So what does this all mean? If you are planning your career right now, you are not competing with a robot's physical strength.
You'd lose that competition anyway.
Exactly. Instead, you are preparing to manage, train, and supervise these fleets. But, and this is a big but, introducing a new autonomous ecosystem brings up massive ethical and legal questions.
Oh, the unresolved issues are massive. The technology is moving way faster than the law.
For instance, the source asks, if a humanoid causes an accident, who is liable? Say it's in a warehouse, it miscalculates and drops a crate on a human worker's foot.
Right. Is it the manufacturer who built the hardware?
Or the operator running the warehouse?
Or the AI developer who wrote the software? The liability web is incredibly murky.
And what about privacy? If we have walking cameras and microphones in our homes and workplaces, because they have to constantly observe their surroundings to navigate safely.
Yeah, a massive stream of spatial data.
How is that collected and stored? And what about unsupervised care? Should a humanoid be legally allowed to care for children or the elderly alone in a room?
And the text even touches on the use of humanoids in police and military scenarios, which is heavily debated. This raises an important question. How much decision-making authority should we actually give a machine operating in the physical world?
Especially one that can physically alter its environment. And these aren't just theoretical questions anymore. They're becoming urgent, real-world problems.
Because the global race is pushing them into our spaces right now.
Exactly. So to summarize this whole journey, the humanoid revolution isn't just a tech story about gears and code. It is a profound shift in work, aging, safety, privacy, and our economy.
It touches everything.
It really does.
Yeah.
And I want to leave you with one final thought to mull over, building on what the source material is really getting at. If physical AI can eventually replicate the heavy lifting and repetitive physical motions of your day, what are the uniquely human skills? The empathy, the complex problem solving, the creativity that you are left with?
That's a powerful question.
Because that is where your true future value lies. Thank you for listening, and stay tuned for more interesting topics here on Inside the Future.